Alright, so this is officially my first math video. Please criticize it, because I'm not actually a teacher, but I do want to get better at it. I mean, I'm better at doing the stuff rather than explaining it. That's basically what I'm trying to say. But, I edited a crap ton of this because it was just me stuttering the entire time. You know, that's why I had to re-record it. But, here we go. So, let's say we have three shapes. So this is going to be a lot more conceptual when you watch this video, but this will be able to, help you think, which is the main idea of these algebra videos. So we have a square, circle, and triangle. Now, in some odd way, they're actually all related. Have you ever been in kindergarten where, like, you just put random shapes on top of each other and make them, like, fit, or something stupid like that? Well, let's take that idea and let's pretend we're Greek. 2,500 years ago. So we'll connect this triangle and this square just to understand what the Greeks were thinking of. I'm not going to cover too much of this because, I might cover it maybe 20 seconds. I don't think it's a very hard concept. But we have the Pythagorean theorem, which is composed of those two components, and it goes a squared plus b squared equals c squared, which is very basic, but this is actually the first time abstraction was used, and this idea is used basically in multiple fields. This stuff literally led to different things in number theory, and the 300-year-old Fermat's last theorem, which was quite disgusting to look at. I read that, 180-page proof or something like that? But let's put this into the Cartesian coordinate system, which I think was created by René Descartes, and I think he also created analytic geometry. I think he did that with Fermat, but I'm not really into mathematic history. I'm just into doing it. So we'll call this right here delta x, because delta means change. That's what the notation would be, which means x final minus x initial. And we'll call this xf minus xi. And then we also have delta y. I'm not going to go through how he discovered that. I'm just going to say that we're going to call this the m equals delta y over delta x, or the slope. But the thing is that I think I defined this as being the same triangle as the one that Pythagoras was using, or just when we were Greek. So if we use that, then we can say that m is equal to c from what I was describing. So since that happened, and if you don't know, it's those two are called legs, and the top one is called hypotenuse, which is the longest part of the triangle, though I'm pretty sure most of you would have known that. So let's just start plugging these in. Alright, so we have c equals m, so we put in m squared, or delta y over delta x squared. So now that we have our equation, let's just think about it this way. We define the triangle to be equal to the one that we were using as a Greek. So doesn't delta x and delta y equal just plain x, as described in that? So now we can basically say it's y squared over x squared. And I think this might be a way to prove it, though I'm not sure. I never actually looked at it. I just assumed that it was right, because when you use it, it works. So when you, if you know how to remove the fractions and all that, you can just multiply the x squared to the other side, and you'll get x to the fourth, which is by the exponential rule, or whatever you call it. And then you have it x squared plus x squared, y squared, and then minus y squared. And that leaves us a quadratic formula, which you can square root it. I think you can square root it, but if you use that, you'll end up with a result that you might be able to use. I'm not too sure. I just came up with it as I was working it. I mean, probably people have thought about it before, so I'm not going to say I just created it. I'm just saying that this is the first time I actually thought about it. But let's move on from this. What if I told you that a triangle and a circle are basically the same thing. I want you to think about it. I mean, I'm not saying that they're the same shape, that just doesn't make any sense, that's stupid. But if you're not sure about functions, it's just plug-in values. But let's say that a circle is just a form of the triangle that's a function. That's all I can really say about it. Because if you were to map a triangle and you had one side that just had no value, then wouldn't that still be a triangle? I mean, if you're using the definition of the Pythagorean theorem. I mean, how about I just do it this way? I'll use the Cartesian coordinate system. Well, I'll talk about that later, but I just want you to think about this. I mean, this is such an easy concept to grasp. All you have to do is just think about it. Because Pythagoras couldn't have been any smarter than any of us, in spite of him creating this theorem, because we have more knowledge known to us than they did. All we have to do is just learn it. I mean, algebra is just basically imagination. That's all I can really describe it as. And actually, I'm pretty sure that's all I have. I mean, just now, I just related all of these shapes, but I just need to know if I did a good job on it. Because there are probably mathematicians all over the world that are definitely smarter than me that could have explained this better, but just take this concept and think about it. But otherwise, God bless you. See you in the next video.